Hello friends, welcome to this video, and in this video we'll be seeing the logic for our customized power function, and we are going to see both the ways. One is the iterative way and the other is the recursive way. So first I will walk you through the iterative way of writing your own power function for a positive number and a positive exponent. Now the for writing it in an iterative way, I am taking a variable called result and I am initializing it a value of 1, and I'm only, since my number is always positive, I'm just ensuring it the number is positive, and then I am going to repeat my for loop till the exponent times, that is the power times. Okay, so I will iterate that and I will compute the value, that is nothing but multiply it recursively, not recursively but iteratively, till power times that particular number, that particular given number. Okay, and then return that result directly, and in case if the power is 0, I just return 1 because anything to the power of 0 is 1. Okay, so this is the iterative style of computing the power function. Sorry, this is the iterative style of computing the power, and the time complexity of this is order of power, big of power, because we are iterating the power, because we are iterating it that many times, and the space complexity is just a constant space complexity. Yeah, that's the iterative solution. It's very simple and straightforward. And then we have the recursive way of implementing the same thing, where we have the base case where we check if the power is 0, we just return 1, or else we compute the recursive power. We recursively iterate this and we divide it into a sub problem, and then we store that result in an auxiliary variable, and we just check if the power is divisible by 2. We just break it into the sub problems, two sub problems of uh, these two sub problems, and if it is not, the power is not divisible by 2, we multiply the values returned by these two sub problems with the actual number. So basically what is this logic doing over here is, basically I'm saying, if I have multiplied 4 times, I just break it down into two sub problems like this. Okay, so this is pertaining to this if case. Okay, and if I have, let's say, needed to raise it to the fifth power, then I do it like this. Okay, so that's the basic thing going on here. So uh, that is the recursive way of doing this, and the time complexity of this would be log to the exponent, big O of log exponent. Okay, so log power, and the space complexity would also be the same, because the recursion tree depth would be this value. That is the recursive way of doing it. And what if we have a negative value of this power? So of course, when we are doing it negative, then we have to do 1 by the number. So of course, 1 by something, it's a float value. So I'm taking everything in floats, float as a float variable over here, and I'm taking a float number, and then uh, in the recursive way the logic still remains the same, except you can see this, it's exactly the same replica, but here just I am doing 1 by number instead of just writing number. Okay, so that is the small change. And in the iterative way also, I have a small change. Instead of writing less than power, I have kept greater than power. I have decremented the counter variable, and instead of multiplying it with num, I am just multiplying it with 1 by num. So yeah, that is the iterative way and the recursive way, and the time complexities remain the same. So yeah, that is the power function. You're writing your own customized power function for positive exponents and for negative exponents, and in both the iterative style and as well as the recursive style. Yeah, so that's it for this video, and So I have a small example as well. So 2 to the raised 2, and let's see it in both the ways. First I will show you to you in iterative power, and also I will show it to you 2 to the raised negative power as well. So let's see. So yeah, 2 to the raised 2 is 4, 2 to the raised minus 2 is 0.25. That's great. And now I will show you the other way around. So here this is using the previous one was using the iterative approach for both positive and negative exponents. This is with the recursive approach for both positive and negative exponents. Let's run this program, and yeah, we are getting the same result. So that is about the recursive and iterative styles of solving this problem. Yeah, so that's it for this video. Thanks for watching.